Hello students, in the last class we learned about the nomenclature of haloalkanes. In this class let us learn about nomenclature of haloarenes and the general methods of preparation of haloalkanes and haloarenes. Let us see how to name the aryl halides, that is halogen attached to the aromatic ring. For aryl halides, both in the common system as well as in the IUPAC system, it is to be named as haloarene. That is, first write the name of the halogen and then write the name of the aryl group. That is, in the aryl halides, both in the common system as well as in the IUPAC system, it is to be named as haloarene. That is, first write the name of the halogen, then write the name of the aryl group. When the aryl halides having the two halogen atoms, and the compounds are generally to be represented as dihalogen derivatives. That is, for dihalogen derivatives in the common system, the position of the halogen atoms are represented by using the prefix. That is, O is nothing but ortho, and P is nothing but para, and M is nothing but meta. That is, in the common system, the position of the halogen atoms are represented by using the prefixes ortho, para and meta. For example, let us consider this is benzene ring. In the benzene ring, one of the hydrogen atom is replaced by the halogen. So the halogen attached next to carbon atoms or next positions are to be called as ortho positions, and the next positions are to be represented as meta positions, and the halogen attached carbon opposite carbon is to be represented as para position. But in the case of IUPAC system, the position of the halogens are represented by using the numerals. That is 1, 2, 1, 3 or 1, 4. Let us see how to name the dihalo derivatives. That is, first let us take the aryl halide having one halogen atom. That is, in the both common system as well as in the IUPAC system, so the molecules are to be named as haloarene. That is, first to write the name of the halogen. Here the halogen atom is chlorine, that is to be represented as chloro, and the name of the aryl group, the name of the aryl group is to be represented as benzene, so it is chlorobenzene. And one more example, that is Br is attached to the benzene ring. The molecule is to be represented as bromo, and the name of the aryl group is to be represented as benzene, so it is bromobenzene. Let us take dihalogen derivatives. That is, two halogen atoms are attached. And one more example, that is the second halogen atom is attached at the meta position, and in the third molecule the halogen atom attached to the aromatic ring, and the second halogen atom is attached at the para positions. Here the first molecule is to be represented as in the common system, that is ortho, and because of the presence of two halogen atoms it is to be represented as dichloro, ortho, dichloro, and the aryl group name is benzene, ortho dichlorobenzene, and the second molecule is to be represented as meta. M prefix is used because the two halogen atoms are present at the meta positions, hence it is to be named as meta dichloro, and it is benzene. Benzene is the name of the aryl group. And the third molecule is to be named as para. That is, the two halogen atoms positions are represented as para, that is P, and dichloro, and it is benzene. That is, these are the names according to the common system. And in the case of IUPAC system, the molecules are to be represented as, that is the first molecule, the position of the halogens are represented by using the numbers. That is, the two halogen atoms are attached to the first carbon and the second carbon. So the position of the halogens are represented as 1, 2, and because of the presence of two halogen atoms, it is to be represented as di, and the halogen name is to be represented as chloro, and it is benzene. So 1, 2 dichlorobenzene. And in the second molecule, the numbering is to be done from the carbon to which the halogen is attached, and keep it in mind, the molecule having least locant, that is, numbering is to be done by the two ways, that is from this side and from this side, that is anti-clockwise direction and clockwise direction. If we done by the anti-clockwise direction, in that case the locant numbers, that is 1, 2, 3, 4, 5, that is locant is nothing but sum of the position of the halogen atoms. Here the locant is 1 plus 5, that is 1 plus 5 is equal to 6, and the numbering is done by the clockwise direction. In that case, locant number is 1 plus 3, that is halogen attached to the first carbon and the third carbon, and the sum of the positions of the halogen atoms to the carbons is equal to 1 plus 3, that is equal to 4. That is, the correct method is the molecule having the least locant number. Hence, the position of the halogens are to be represented as 1, 3 and dichloro, 1, 3 dichloro, and the name of the halogen, that is aryl group, is to be represented as benzene. And the third molecule is to be represented as, that is numbered as 1, 2, 3, 4, and the position of the halogens are to be represented as 1, 4, and because of the presence of two halogen atoms, it is to be represented as di, and it is chloro, dichloro, and the name of the aryl group is benzene, dichlorobenzene. That is, in the common system as well as in the IUPAC system, the aryl halides are to be named as haloarenes. Aryl halides are to be named as haloarenes. And if the molecule contains two halogen atoms, in that case the position of the halogen atoms are represented by using the prefixes. That is, in the common system, ortho, meta, para are used, and in the case of IUPAC system, the numerals 1, 2, 1, 3 and 1, 4 are used. Let us take one more example. And in the second molecule, that is two halogen atoms are attached, and the second halogen is attached at the meta position. And one more example, that is the molecule which contains three halogen atoms, that is Br, Br and Br. So the first molecule is to be named as bromobenzene according to IUPAC system as well as in the common system. And the second molecule is to be named as, that is meta-dibromobenzene, because the halogen atoms are present at the meta positions. And in the case of IUPAC system, it is to be represented as, that is 1,3 dibromo, and the name of the aryl group is to be represented as benzene. And the third molecule, that is, it contains 3 halogen atoms, and the position of the halogen atoms are in the symmetrical nature, that is, alternative carbon atoms contains halogen atoms. Hence, the molecule in the common system is to be represented as symmetrical, SYM, that is symmetrical, and the molecule contains 3 halogen atoms, so it is to be represented as tri, and the halogen name is bromo, and the name of the aromatic ring, that is benzene, symmetrical tribromobenzene. And in the IUPAC system, it is to be represented by writing the position of the halogen atom, that is first carbon, third carbon, and fifth carbon contains halogen atoms, that is 1, 3, 5, and tribromobenzene. Let us take one more example, the derivatives of benzene, that is one of the hydrogen atom in the benzene ring is replaced by the methyl group, to which the halogen is attached, that is halogen is attached to the aryl group by replacing one more hydrogen atom. And another molecule, that is, and one more example, that is benzene ring, one hydrogen atom is replaced by the CH2Cl. So the first molecule according to common system is to be represented as ortho, that is the methyl group as well as Cl are present at the ortho positions, so it is to be represented as ortho, and the name of the halogen is to be represented as chloro, and the aryl group is to be called as toluene, that is orthochlorotoluene. And in the case of IUPAC system, it is to be named as, that is numbering is starts from the carbon to which the halogen is attached, that is 1 chloro, and the second carbon contains one methyl group, so it is 2 methyl, 1 chloro, 2 methyl, and the aromatic ring is benzene, 1 chloro, 2 methyl benzene. Or this molecule is also to be represented as 2-chlorotoluene, that is, so this substituted benzene ring is to be called as toluene, and the position of the halogen is represented as 2, and the name of the halogen chloro, that is 2-chlorotoluene. And the second molecule is to be named as benzyl chloride according to common system. In the IUPAC system, the molecule is to be named as, that is for the parent chain, this CH2 group, 2 substituent groups are attached, one is phenyl group and another one is chlorine. According to alphabetical order, C comes first, hence it is to be named as chloro, phenyl, and the root word is meth, and it contains only single bonds in the root word, so it is to be represented as ANE. That is chlorophenylmethane. Very important. Phenyl is to be considered as a substituent group in the molecule. That is chloro and phenyl, and it is methane. Next we'll go for the isomerism. Haloalkanes generally exhibits two types of isomerism. One is chain isomerism and position isomerism. Let us learn one by one. First one, chain isomerism. That is, in the first year already we learnt about the chain isomerism. That is, it is a phenomenon in which the molecules having the same chemical formula but differ in their number of carbon atoms in the chain. That isomerism is generally to be called as chain isomerism, and the molecules are to be called as chain isomers. If a haloalkane has 4 or more carbon atoms, it can exhibit chain isomerism by making a branched or straight chain compound. Let us take an example, butyl bromide. Butyl bromide has 4 carbon atoms. The formula for the molecule is to be represented as CH3, CH2, 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 and it is Br. So but is nothing but 4 carbon atoms, that is 4 carbon atoms, and the halogen is bromide, so it is butyl bromide. And another isomer of the butyl bromide is a branched isomer, that is CH3, CH, and there is one methyl group, CH3 and CH2, it is Br. So butyl bromide gives two types of isomers, that is both the molecules having the same chemical formula but differ in the number of carbon atoms in the chain. Hence the molecules are generally to be called as chain isomers. Chain isomers, and the phenomenon is to be called as chain isomerism. And next, position isomerism. That is, position isomerism is the phenomenon in which the molecules having the same chemical formula but differ in the position of the functional group. That is, alkyl halides with minimum 3 carbon atoms for the monohalides and 2 carbon atoms for the dihalides exhibits position isomerism. Let us take an example, that is propyl bromide. So propyl bromide, prop is nothing but 3 carbon atoms, that is CH3, CH2, CH2, and it is Br. So it is to be called as propyl bromide. And the position isomer of the propyl bromide is to be represented as CH3, CH, CH3, and it is Br. That is, the first molecule is to be named as, that is 1-bromo and propane. That is the IUPAC name of propyl bromide for the first isomer is to be represented as 1-bromopropane, and the second isomer of the propyl bromide is to be named as, that is first give the numbers, that is 1, 2, 3. Second carbon contains halogen atom, so the position of the halogen is to be represented as 2, and it is bromo, 2-bromo, meth, eth, prop, 2-bromo prop, and the nature of the bonds ANE. That is, the propyl bromide has 2 isomers, that is 2 position isomers. One is 1 bromopropane and another one is 2 bromopropane. That is, propyl bromide is an example for the monohalide because it contains only one halogen atom. So because of the presence of one halogen atom with the minimum of 3 carbon atoms, it shows positional isomerism. And for example, let us consider the molecule having the 2 halogen atoms, CH3, CH, Cl2. That is, 2 halogen atoms are attached to the same carbon atom, hence it is to be called as geminal dihalides. Geminal dihalides. And the 2 halogen atoms are attached to the adjacent carbon atoms. Adjacent carbon atoms, it is to be called as vicinal dihalides. Vicinal dihalides. These two are the positional isomers of dichloroethane. So the first molecule in the according to IUPAC system is to be written as 1,1 dichloroethane, and the second molecule according to IUPAC system is to be represented as 1,2 dichloroethane. That is, the monohaloalkanes with the minimum of 3 carbon atoms and the dihaloalkanes with the minimum of 2 carbon atoms exhibits positional isomers. Next we will go for the nature of CX bond in the alkyl halides. For example, let us take methyl halides, that is to be represented as 3 hydrogens and 1 halogen. Here the electronegativity of halogen is greater than carbon, due to which the shared pair of electrons in CX bond lies closer to the halogen atom. That is, the shared pair of electrons are slightly shifted towards the halogen atom. Because the halogen is more electronegative atom than carbon, hence it pulls the shared pair of electrons towards itself. As a result, the halogen atom bears a partial negative charge and the carbon atom bears a partial positive charge. So it is to be represented as delta minus and delta plus. As we go down the group in the periodic table, the size of the halogen atom increases. That is, halogens are fluorine, chlorine, bromine and iodine. So as down the group, the size of the halogen atoms increases. Down the group. Here fluorine atom is the smallest and the iodine atom is the largest. Consequently, the carbon halogen bond length also increases from CF to Ci. That is, the carbon halogen bond, that is CF bond, is less as compared to the CCl bond, and CCl bond length is less as compared to the CBr, and CBr bond length is less as compared to the Ci, because as down the group, size of the halogen atoms increases. Due to the increase in the size of the halogen atoms, the bond length also increases. Due to the increase in the bond length, the bond dissociation enthalpy decreases. That is, bond length is inversely proportional to bond dissociation enthalpy. Hence, as down the group, size of the halogen atoms increases. Due to increase in the size of the halogen atoms, bond length between the carbon and fluorine increases. Due to increase in the bond length, the bond dissociation enthalpy decreases. That is, bond length is inversely proportional to the bond dissociation enthalpy. Further, as we move from fluorine to iodine, the electronegativity of the halogen also decreases. That is, the electronegativity of the halogen atoms. Fluorine is more electronegative than chlorine, and chlorine is more electronegative than bromine, and bromine is more electronegative than the iodine. Therefore, the polarity of the CX bond decreases accordingly. It is CF is more polar as compared to the Cl, and Cl is more polar as compared to the CBr, and CBr is more polar as compared to the Ci.